Okay, so like I was just saying, probably the first thing you need to know here is perfect squares are going to be really important today. And I'll talk about why in just a second. But I want these numbers to like jump off the page at you. All right, so when you see 1, 4, 9, 16, 25, 36, 64, 81, 100. And I kind of went a little overboard up on the board there. I would say usually if you know up through 144, you're good. We could keep going. But really where I generated that list from was doing 1 squared and then 2 squared and 3 squared and 4 squared and so on. Okay. So let me just talk about why those things are going to be important today. Today we want to try to find exact answers when we're doing the quadratic formula. And the best reference point I can give you for exact answers was in geometry. Geometry, you had to do exact answers sometimes when you worked with circles and pi. And do you remember how, like, if we said exact answers, we wanted you to say 4 pi instead of giving me like a decimal version of pi? Okay, does that ring a bell? Okay, so the reason we did that is because pi is a decimal that goes on forever. So if you use the decimal version of pi, no matter how many numbers you write down, at some point you're cutting it off, right? And then it's not accurate anymore. That happens also with some square roots. So if you try to take the square root of a number that's not one of these nice, happy, perfect squares, you get one of those long, crazy decimals. And you had some of those in your assignment yesterday where you did the quadratic formula and you got some decimals when you did the square root piece. And we just said it was okay for them to be decimals. But today we want to try to avoid using decimals for those. Okay? And so we're going to do something called simplifying radicals. So first I'm going to show you how to simplify radicals. Radicals is just a fancy word for square roots. And then after we're good at that, we'll put that inside the quadratic formula and put it all together. Okay? So here's what I mean when I say simplify radicals. And I'm going to do a separate one besides these two. You can write it down if you want. You don't have to. If I take, for example, the square root of 20, that doesn't break down nicely, right? Like I can't take a square root of 20 and have it come out nice. All right? But I could rewrite that square root of 20 as the square root of 4 times the square root of 5. Why do I like that particular combination of numbers? First of all, do you agree with me? Can I rewrite square root of 20 that way? Square root of 4 times square root of 5? So why do I like that combination? What's good about it? Asa?
Perfect square.
Okay, the square root of 4, I could rewrite that as just a regular old 2, right? And I can make this 2 times the square root of 5. This is a simplified version of the square root of 20. Okay? That's kind of our goal. So when I just say simplifying radicals, that's what I mean to do, is to write it like that. Okay? But then when it's inside the quadratic formula, there's some other stuff you can do with it. Like there's a reason that you would have to do all of that. Struggling with how to adjust this best. Maybe I just need to tilt this without knocking my document camera. Okay. Now notice I picked that combination for a reason. If I had done like square root of 2 times square root of 10, that is true, right? Like 20 is 2 times 10, but that wouldn't have gotten me anywhere, right? So the whole idea is to take the number that you're working with and write it as like something times something, where one of your somethings is one of my perfect squares. And that's why it's so important that you know those perfect squares off the top of your head, okay? So we're going to try that, and I'm going to kind of just section this off so that you know it's not part of these other problems. But square root of 50. How can I write that using one of my perfect squares? Cassidy?
The square root of 25 times the square root of 2.
You got it, yeah. So we could say this is like square root of 25 times square root of 2, okay? Because this multiplies to make 50. And now I can say square root of 25 is just a 5. So now my answer is, whoops, and I'm writing another 5. 5 square root of 2. Okay, that's how you simplify a square root. Does that make sense? You okay with that? Good. Try the 108. See if you can come up with a combination that works for 108. And there's a couple different combinations that work, so it's okay if you come up with more than one. Anyone think they have one? Combination that works for 108? Someone's got something. Andrew, what do you got? Okay, so square root of 36 times square root of 3. Okay, now I'm betting Andrew does not walk around knowing that 36 times 3 is 108. I'm guessing you probably had to take that 108 and divide it by stuff until you found one that works. That's totally okay. Sometimes you have to take the number and just start dividing it by these numbers until you find one that works. What's another combination? Anyone come up with a different one? Yep, Christian. Yep, square root of 9 times square root of 12. Any others floating out there? No? That's it? Toby? I knew there was one more out there. Yep. Square root of 4 times square root of 27. Okay. All of these are correct. The question is, which one's the best? Any thoughts? Christian, what do you think?
The one that, like, after you do the square root on the perfect square is the smallest number.
That's right. Yeah, so you want to try to get this piece that's left over to be as small as possible. You want to get it reduced down as far as you possibly can, okay? Now, sometimes what happens is you do something like this, but then this can be reduced further. So watch what happens here. If I do this one, square root of 36 is 6, so I would get 6 times the square root of 3. That's as far as that one will go. But if I look at this one, this is 3 and then square root of 12. But then think about 12 for a second. Are there any perfect squares that go into 12? Say it again.
144.
Perfect squares that go into 12. So 12 squared is 144. But what goes into 12? 4, right? So this could break down further as square root of 4 times square root of 3, which means this square root of 4 is really a 2. And then if you look, 3 and 2 put together would give you that 6. And then you would still have this square root of 3 sitting out there. Okay? It's kind of like when you're reducing fractions. You know, if I gave you something like, I don't know, 24 over 36, some of you might start by dividing by 2 and then dividing by 2 again. Some of you might start by dividing by 6, I think would work, and then seeing if anything else would go in there. And some of you would jump straight to dividing everything by 12, okay? It's really just a matter of how many steps do you want to take. By the way, the same thing would happen here because 27 could be square root of 9 times square root of 3. Square root of 9 is really a 3. Oh, and this is a 2. That was a 2. So if you put together the 2 and the 3, you would get that 6 from right here, and then there's your square root of 3. Okay? So if you have a hard time thinking with the bigger numbers, go ahead and start by just dividing it by a 4, dividing it by a 9, divide it by something smaller, but just be ready to check that thing that's left over to see if anything else can come out of it. Does that make sense? Feel okay about that? You feel okay about reducing radicals in general before we throw it into the quadratic formula? Yeah, Ashley?
So no matter what, like even if you did like on all of them, like say if it wasn't like 36, obviously if there's like other ones in that, like they would all always reduce to the same thing anyways.
Yes. Yeah.
So it doesn't really matter.
Yep. Yeah. If you wanted to do this, that's okay as long as you know to take it a step further. Yep. They should always reduce the same way as long as you reduce it as far as it would go. Okay? Okay, so now let's talk about how that applies to the quadratic formula. You'll notice that here in example 4, it says give exact solutions to this equation. Now, the fact that it's asking for solutions, that's what tells me that I'm using quadratic formula, okay? But the fact that it says exact means I don't want to throw messy decimals out as my answer, okay? We're going to do some reducing of radicals here. Now, what I will tell you is these answers all come out a little bit different, and they all simplify like to different points. I didn't want to do like 10 examples to show you all the different, like, well, what if this happens? What if this happens? So we're going to do these examples, but then after each one, I'm going to kind of show you like some other possible things that could have happened. Okay, and then hopefully I'll have covered my bases. But all right, let's set this up with quadratic formula. -8 plus or minus square root of 8 squared minus 4 times 2 times 2 all over 2 times 2. Remember to start with just what's inside the square root there. That's 64 minus 16. This right here is equal to 16. So that's going to be a 48. Everyone okay with me up to that point? That's just quadratic formula, like what we did yesterday. Now, yesterday at this point, we would have just slapped that square root of 48 into our calculator and gotten a decimal and moved on with our life. Today, we can't do that, okay? What we have to do is we have to simplify that square root of 48. So think about your perfect squares. Remember, you're shooting for the biggest one you can find that goes into 48. Anyone think they have it? Natalie? 16 and 3. Good. So instead of square root of 48, I'm going to turn this into square root of 16 and square root of 3. Okay? Which then allows me to say this is -8 plus or minus square root of 16 is 4. And then that square root of 3 is just going to stay there. And then I have a 4 on the bottom also. Okay with what I did there? That was just like what we were doing a second ago, but it was inside the quadratic formula. All right. Now, normally at this point we would split and we would do like 1 plus and 1 minus. We can't really do that because we can't really add these two things together. Okay, it's like they're not like terms. So I can't go any farther that way. Does anyone see anything else that would simplify here? Christian? Okay, I can cancel out the 4s. The thing you have to watch out for with this though is see how I have like 2 things on top and they're both being divided by 4? Technically this is being divided by 4 and this is being divided by 4. So I can cancel those 4s, but I want to make sure I divide it with the 8 as well. Okay, so -8 divided by 4 is -2. And then plus or minus. My 4s would cancel there. Technically, they make a 1. And then square root of 3. And this right here would be my final answer. Okay. I'm going to throw some what ifs at you inside again. We feeling okay about that one? Ashley.
I like the test or whatever, or quiz, but would you be able to like use your calculator for this part, like finding out the first equation?
That's a great question. So, and I'm going to explain this a little more once we actually get to the homework too. You have a quiz next week where you can't use a calculator at all, okay? And it does have some quadratic formula stuff and some other stuff on it. The quadratic formula ones that I make you do without a calculator, I make the numbers very reasonable, like they're very small. They're things that you should have no problem doing in your head, okay? When it comes time for test time, the numbers get a little bigger, but you can use your calculator for that piece of it. So yeah, you definitely can still use your calculator to do the number crunching for the most part. Like I said, other than your quiz next week, but we'll practice for that separately. But you just don't want to do any of the square roots in your calculator if it's asking you for an exact value. Now, when it comes to this reducing step, I want to show you one other thing that happens sometimes. Sometimes you might get something like this. -6 plus or minus 2 square root of 5 all over 4. Let's say you end up like with something that looks like that. Technically, I can't really divide these by 4. I mean, I could, and they would be decimals. And that's not terrible because they're not like long decimals, all right? So, but I can't divide them nicely like I could here. See how here these both divided by 4 really nicely? But what could I do with 6, 2, and 4 if I'm thinking about like fractions? Look, I'm here mumbling. Asa, did you say something? Okay, I could if it was equal to something on the other side, and I was trying to cancel it out. As it is, I'm just trying to simplify. Christian? Say it one more time. Okay, so if you're getting closer. If you multiplied everything by a common number, then all that would happen is I would be able to divide it back down to like this, right? So if I multiplied them all by 5, let's say, then I'm going to be able to just divide by 5 later on. What if, think about it in this perspective. What if I wrote this separately? -6 over 4, and then 2 square root of 5 over 4. What can I do with that? Besides just dividing it and making it a decimal. Divide by 2, right? And doesn't this divide by 2 also?
Yeah.
So what I could do is take all 3 of these and divide them all by the same number. So not really multiply by the same number, but divide by the same number. I could say I'm dividing everything by 2. So now this is a -3, this is a 1, this is a 2. It's like reducing a fraction. Oh, yeah. It's like reducing a fraction, but you have 3 numbers to play with instead of 2. Okay? You're reducing all of them. And then you would say your final answer is -3 plus or minus square root of 5 all over 2. Okay? Does that piece of it make sense? That you can, those numbers on the outsides, treat them like a fraction. Okay? And so you can reduce them like fractions, or if they just divide, you can divide them. But all of your regular fraction rules apply. Okay? Just remember that you do have to work with all 3 numbers. You can't just pair up 2 of them and ignore the 3rd one. Good? All right, let's set up that next one. What am I going to have to do with this next problem before I can even start? Yeah, I have to get it all equal to 0, right? So I'm going to rewrite this as 0 equals -x squared plus 9x plus 11. Some of you may have thought to move the 9x and the 11 over to the left. That would have been okay too. All your positives and negatives would have been backwards from mine, but it all would have worked out okay in the end. Okay? So when I set this one up, -9 plus or minus square root of 9 squared minus 4 times -1 times 11 all over 2 times -1. So this is kind of what I'm talking about, Ashton, to answer your question from earlier. These numbers are a little bit big for what I would ask you to do without a calculator, okay? However, I'm about to show off and do it without a calculator. This is 81, this is positive 44, and 81 plus 44 is 125. So that would be -9 plus or minus square root of 125 over -2. What now? Christian, go ahead.
Do you take the square root of 125 and make it the square root of 5 times square root of 125?
I like that. Yeah, we need to break down that 125, right? And Christian's suggesting 25 and 5. Are we good with that? Okay, remember you're looking for a perfect square. So square root of 25 times square root of 5. So that's now going to be -9 plus or minus 5 times the square root of 5 all over 2. Can I reduce that at all? Not really. Jack, what were you going to say? Oh, I lost my negative. You're right. Thank you. Yeah, it is still -2. 9, 5, and 2, there's nothing I can like divide out of those. Would it be the end of the world if you made that a 4.5 and a 2.5? No, because those decimals are not irrational decimals. But usually if you can't divide anything out, we just leave our answer like this. This is just your final answer. That's as far as it goes. Okay? Let me throw a couple more what ifs your way and then I'll turn you loose. Let's say let's say you came down to something like this, plus or minus square root of 21 over 5. What can you do with the square root of 21? Not a whole lot of anything, right? There's no perfect squares that go into 21. So if that happens, I mean, sometimes your radical just can't go any further. Sometimes that's just it. Okay, sometimes you can't even pull anything out front. Okay? The flip side to that, what if I gave you something like this? 4 plus or minus square root of 100 over 2. What happens with that square root of 100? You can just take the square root of 100, right? You don't have to like simplify it. You don't have to find a perfect square. It is a perfect square. So you would just say this is 4 plus or minus 10 over 2. The thing with that is you can actually solve that now, right? Because it doesn't have the radical in it. You don't have to stop. You can say, well, now I can do 4 plus 10. Sorry, I'm running out of space here. Over 2. And 4 minus 10 over 2. And then you can say, well, 14 over 2 is 7. Here you would say negative 6 over 2 is negative 3. And so on those ones, you can simplify it all the way down to the answers, right? So all of these can simplify like to different degrees. Sometimes they simplify a lot. Sometimes you kind of just put the numbers in and then you stop because that's as far as they go. So the whole idea is just to simplify them as far as you can get them without throwing any of those square roots in your calculator. You feel ready to try a few of these? Okay. All right, let me get this shut down then real quick.